All right, guys, today we're going to talk about Excel. The best way to learn Excel is to do Excel. So there is a file called Engineering 115 demo that is in your files on Canvas. So go to the files on Canvas, download that file, and then pull that up, go ahead and split screen this video and that. Your quiz questions will come off of this video from various places. So let's make sure you do that so that when we get to class, we'll all be on the same page and you guys can work through some more beneficial activities during class. All right, so Excel. Excel is a spreadsheet program that's used by engineers and scientists and business people and accountants all across the world. So it was originally the spreadsheet was used mostly by accountants and business people for ledgers and things like that. And they moved to computers when computers came around. So engineers and scientists jumped on board as a way to handle data. You can see that it is a business function later on when we get into making plots. There's a lot of pie charts and bar charts, which aren't necessarily most beneficial for us as engineers and scientists. Sometimes they are, but usually we're looking for something more like an XY chart option, and there aren't as many options there. There's also some built-in calculations like rate of return, which can be beneficial to us, but it's not our day-to-day thing like calculating a torque or a moment or something like that. So it definitely is there. We have supercomputers that run really big sets of data, and we have different programs that can do that. But if you're in like a time crunch where we need just a smaller amount of data, Excel a lot of times is very good. So it's good for, these spreadsheets are good for performing the same calculations repeatedly, working with tabular information, so steam tables, things like that, producing graphs, simple graphs, performing what-if analysis, so what would happen if the flow rate would double, and then presenting results in a readable form. And it's used across multiple disciplines, multiple companies. Almost everyone has Microsoft Word, so that's a good reason to use it. So as we start out, one of the first things I want to do is this spreadsheet, just like any piece of paper, when I come in, it starts out with sheet being named sheet 1. So I want to name this sheet like I would a problem. So if this is example 1, I want to name it example 1. And the next thing I want to do is I want to put some information up here at the top that identifies what's going on. So I want to put my name and the date. So that I can identify it. And something else I might want to do is put the purpose of what we're doing, or eventually maybe given finding solution or something like that. Just so later on when people come in, they know what's going on and they don't have to guess at what we were trying to do. So the purpose of this is to demonstrate some basics of Excel. So looking at this, I might want to bold these, so I can either come to the Home tab and highlight those cells and then click bold, or I can highlight these and then hit Control B. Maybe I want my purpose to be in italics, so I can hit Control I, or I can come up here and click I. Something else that was kind of frustrating here, and just from a perspective of someone who cares about the way things look, if you notice this is left justified, this is right justified. So if I want everything to be left justified, I can highlight it all and left justified, so it all matches. Also, I've got just some dead space in this cell. So if I want my cell to be as small as possible, I could drag it until I get just about the right. If I go too far, it cuts off some data. Or another cool trick is when I come up here, you can see my cursor changing. And when I get this line with an arrow going either way, if I double click, it will adjust to the right length. So I can do that for each of these, and then all of them are in the correct. The cell is the smallest it can be for the data that is in that cell. Something else, maybe I don't want this, maybe I really am, this is our only thing that is going multiple rows and we don't need it to, so I can also do something called wrapping the text, so I can make it wrap down. And so that allows us something else, and I can adjust the way the purpose is, whether it's at the bottom of the cell, the top of the cell, or the middle of the cell. So that's more formatting, not really how to use the program, but some useful information to make things look nice. All right, so now that we've done that, we've changed the name of the worksheet to example 1. We've added our name, the date, the purpose, and so we know what to do. So now what I want to do is I want to do something with the data, and I want to add some data to column C and D. I'm going to calculate that data. And so I want to calculate the volume. And if you notice, following the convention of these last two, it has mass, M, in grams, length, L, in centimeters. So I'm going to do volume, V, and I want it to be in cubic centimeters. So cc is cubic centimeters, and then later on I'm going to calculate density, which the sign for density is rho. And in order to get a rho, I can come over here to insert, symbol, and then I can search through until I find some Greek letters somewhere here. And that is rho right there. So this is the small letter rho. I'll hit insert. It's inserted there, and then I can close. And density's units are going to be in grams per cubic centimeter. Okay, so now what I want to do is I want to make this thing a little pretty. So this is ACU, so I'm gonna make it ACU purple up here. So I can come back to home and I can change this bucket to purple. And then that black doesn't look very good on there, so I can also change the text color to white. So that way I can definitely see a difference between what my headers are in my table, of my spreadsheet here, and then what my value, my data is in here. So once I've changed my header row with a different table color, I change the font to white, and I want to change so we're good to go there. Now I want to calculate density, which density is the mass by the volume. And so right now I have mass, I need to calculate volume so then I can calculate density. So in order to do that, I want to assume that this is a cube that I'm looking at. So just some little cube. So a cube has the same length, width, and height, right? So in order to do that, I would just want to cube this. And so when I'm entering the formula, one way I could do this is anytime I enter a formula, I have to hit the equal sign first. So that tells it that I'm going to start using a formula. And you'll see up in this box that this changes. So this is called the name box, and the name box identifies what cell you're in. So if I jump around cells, you'll notice that it's jumping around to each of these. But once I hit that equal sign here, it's going to be looking for a function. So I don't want to put a function there. I want to find the volume. So I want to hit equals. And then I want to take my length cubed. So I can either type in 1.5 times 1.5 times 1.5, which is really inefficient, right? The other thing I can do is I can just click on this cell. So this is called a relative reference at this point. So what it's doing is it's referencing that cell directly to the left, and I want to raise it to the third power. So this caret is our exponent, and we raise it to the third. So that gives us 3.375 cubic centimeters. That's a lot of decimals that I don't need. If you notice here, we only have one decimal, so I can come here, and if I click this button, it will continue to give me more decimals, and if I click this button, it will decrease the accuracy that's there, the number of decimals that are there. So this is really all I need. So now I want to calculate the density or the volume for all of these. So in order to do that, I can drag down. If you notice, when I drag down, I can come and click on this cell and look at what the formula is, and it's referencing a relative reference. So a relative reference says that whatever this cell was, when I drag it down to here, it's going to reference exactly the way this one was. So this one was referencing 1 to the left. So this cell is referencing 1 to the left. If I drag this cell to the right, it's going to reference this 3.4 cell. So just to prove to you, it is taking C6 to the third, which is not what we want, but just for the sake of example. Okay, so another cool trick is if I come to the corner here, you'll see that it turns to a cross, and then I double click. This will fill all of the cells down to the bottom. I could click and drag them down, or I can just double click and it will go down to where the data stops. So now that I have all the volumes for each of these masses, now I want to calculate the density. And the density is just the mass divided by the volume, right? So in order to find the mass divided by volume, again, I'm going to hit the equal sign, so I have a formula, and then I'm going to click on my mass. And the slash sign is divided, which I think you all know, divided by the volume, and that gives me 0.3. Maybe I want this to be a little bit more exact, so I could add a few decimals. And then I can drag it down, and if I drag this cell down, which is A6 divided by C6, take a minute and think, what is this cell going to be if I drag it down? So it should be, if we drag it down, it should be A7 divided by C7. So let's see. Sure enough, it is A7 divided by C7. And then from here, I can either drag this all the way down, like so, or I can just double click and it will automatically fill.